Kevin, would you mind to share your screen? And then meanwhile, I will start the record.
Yeah, sure. Let me share the screen. Um, okay, could you see it?
Yeah.
See my screen? Okay, cool. So hi everyone. So Jerry and I are working on this project, and this is the outline for the talk today. So first, I'll give an introduction to what we are doing and our goal and the directions. And then Jern will talk about the ZKStats library powered by the ZKP. And it's also our first attempt, so our first project. And then I will keep talking about the MPCStats library, which is our current focus, and it's powered by the MPC. Yeah, and then after that is the next steps, and then the potential future directions. Okay, so privacy preserving statistics. So it's a framework we're building. So for user to ask data providers to perform statistics computation. So for example, there are data providers, and data providers has data, and user can ask the data provider about the statistics result of the data. So for example, the median of each column, and then the average, something like that. So in this case, the data provider will just do the computation, the result is returned. So what is different from the usual database is that user can be convinced the result is correct. So user knows that the result is not something data provider randomly return. And to achieve this, data provider doesn't need to reveal their actual data. So and nothing is revealed. So it's our goal of our project. So we want to lower the barrier for average people, for everyone to use privacy preserving statistics. So it's open source, and our target is to make it user friendly. And about the use case, we're targeting scientific research, so people can do statistics operations on the medical and financial data, etc. And we hope as we build this framework, we can onboard more users to use the privacy preserving statistics, and it's possible we can enable more use cases in the future. And so we have three major directions. So as I mentioned, the first is ZKStats library. So user can query to one data provider. So as this diagram shows, and we have a draft library. So we have a first version of library that people can use. So we support 12 statistics operations and data filtering. So it's already usable. And the second direction is the MPCStats library. So it allows user to query computation to multiple data providers, and it's powered by MPC and also our focus. Yeah, and the third one is the platform. So we want to build a web application powered by these two libraries, and it will allow data providers to advertise their data sets, and user can search for the datasets and send the request to the data providers and get the result. Yeah. So it's also ongoing, and our grantee Cathy is working on this. Yeah. So in this talk, we will focus on these two directions: ZKStats library and MPCStats library. And in the next slide, Jern will talk about the ZKStats library. Yeah. So I'll hand it over to Jern.
All right, thanks very much, Kevin. And yeah, let's talk more about ZKStats library. So let's look at a broader level first, right? So we have two parties here: users, which is basically the one who don't have access to data, right? But they can be analysts, they can be student, they can be the one who interested to get some insight from the data, which in this case we call it confidential data sets, because you cannot just provide it all like raw data publicly, right? Because of maybe of the regulation, maybe of the proprietary data, like confidentiality of that. And these all confidential data sets is like hold or like owned by the party called data provider. Again, as Kevin mentioned, right, our first step is to make the protocol work with just one data provider. So basically we just request all these statistic computation from this just one provider. But again, like we mentioned one provider, but it can be multiple data set, right? So it can be dataset 1, 2, or 2n or something like that. So basically we can request statistic computations. So users will basically like see like, oh, which data set that I would like to request some statistic computation on. And it can be mixed between like different data set, right? Some data set may have like different shape, different schema. It's fine as long as it's come from one data provider. So yeah, the flow is basically like user request some statistic operations on this data set that they're interested in. And then data provider and our platform, right, the ZKStats library, basically allows the users to receive a verifiable result, which is like when we mean verifiable, it's just like we need to make sure, like we need to convince users so that like this result that they get actually comes from the data set that they bought, and they actually perform a statistic computation that the user requests. So seeing these pictures, right, there are a few trusted assumptions in this protocol. And the first one is that like, if we say about confidential data set, right, basically public just see this as just an encrypted format, right? Just like some random number from encryption, right? So how can we be sure that the data is really what it claims to be, right? Let's say the data set 1 is say like public data, like the health data of this demographic in this certain city. How can we be sure it's not just data provider don't just put some garbage into the data because it's encrypted, right? And then the second part is that to make sure that the result comes from the user-defined computation, because that's what the user is interested in. And then making sure it's the defined computation on selected data set, which can be more than one, right? As long as it's come from the like single data provider. So basically the first part is very tricky because we will say we trusted by trusted party. And what we mean by that is basically, let's say this data provider is, let's say if it's like by law to not show this confidential, right? This trusted party can be government. And all they do is to basically to making sure that like this dataset 1 that they claim to be, let's say some health like data of this like people in this demographic in this city, they just like need to make sure that this is the result from the true data that like encrypted into that. So I think like we think that this makes sense because like it making sure that like the data provider just don't put garbage into it, and that this trusted party already know the data. So it's fine to like have like check and balance here to make sure that this confidential data sets is really what it is, right? But then the interesting part is that like to make sure that the result come from the user's defined computation or unselected data set. This is where the ZKStats library come in. So let's see how we do that. And if you see the flow here, right, there's a huge gap here. Basically, like how to communicate about like how to say that, oh, I want this certain statistic computation, which can be complicated, right? You can just ask some mean, but you can also do some linear regression. You can ask like mean of median of different data set, this stuff. So basically, you want to have some shared format to represent computation so that the users and data provider are on the same page, so that they understand that, cool, I want to compute or like I want to request some computation over my data set. And actually there's a lot of format in nowadays world, and we want to make sure that we leverage the one that is existed already. And we actually decided to go with Onyx file, which is the format that people mostly use it for the neural network. And we think that like neural network can be applied to in this case because like even though we don't need like some like really deep learning or like deep multiple layers, we can treat each layer as some like layer of like computation of statistic, right? Let's say if you have like want to request some mean of data, you can treat one layer just like mean layer. But then if you want to have like multiples like complex like statistic computation, you can treat different operation as different layers. Let's say like mean of median or like regression of a median or something like that. So we think like Onyx file is a good format to work on, so that like it can communicate between users and data provider what statistic computation, or from now on we will call computation graph, that they want to compute on data. And luckily, when we think about this, like framing this problem in this way, we found out that there's actually a project called ECKL, which is also an open source project, that they, given Onyx format, they can create a CK proof for that. So basically, like right now, we just want to make sure that like users can define computation graph, which can be exported into Onyx file, and then from that point on, we can use ECKL, which is another library, to create zero knowledge proof for that. So let us like look closely at this like workflow and see how that goes, right? So now we have users, I have data provider, again, like data provider commit to data, right? So that they just have raw data and then create a commitment of that. So to make sure it's just like private, right? The public just see the commitment, and then the trusted party verify that data provider doesn't put garbage, as we talked before, right? And then the user just requests for data commitment, right? Oh, I want to know some inside of this data set, and then what data provider, what the platform or the library provide is basically show them like the data shape and the schema, so that user know that like, oh cool, this like Excel file like have this column, may have weight of people, have like height of people or those stuff. And the data shape is pretty like important, because in like Onyx file it's pretty like fixed in the terms of like the shape of like the input. So this is pretty how information, but basically this flow is just for selected data and to making sure that data provider commit to true data, that they like really like honest about that. And then from this point onward, right, this whole flow basically is just dividing the computation graph. We can do multiple ways of this. One like no-brainer way is like just define the computation and then send like code of the computation to data provider, right? And then like both of them can like convert computation into PyTorch, from PyTorch to Onyx file. But again, like we already talked, right, that we have the things called like share format Onyx, right? So basically we can just skip out of these things into just like making users define computation and export it into Onyx file, and then send Onyx file into data provider. So we can shorten this step. There's a few trade-off though, because like most like things cannot really read Onyx file that clear. So basically like in this case, right, because the whole point of this project is to make sure that the user obtain the data, like some insight from data provider without leaking data, right? So it's really dangerous. Let's say if the user define computation like, oh, give me like first 100 raw data like of this data set, right? And then if data provider is like automatically, and then like they're just like, oh cool, approve that, that can leak, right? So the benefits of using like sending the raw code of this, so that data provider can just run them locally and then see like, oh, like what's the result, or like what's the logic behind this computation graph, right? Because it's arbitrary, it's like statistic function, but you can shape it, or like you can manage it to be like, again, like mean, regression, mean of median, like geometric mean, whatever, right? So yeah, so this step is basically just to define a computation graph and send it out, which can be just sent into Onyx, or you can just send a huge code, but it's pretty much the same, not really a lot of work. The work here is, and on the later half is this is called the CKP, right? So this one is, again, luckily because we use the Onyx format, it can be handled by ECKL. So the logic here is pretty simple. Both party has the same Onyx file. On the user and use ECKL to generate verifier, which is really critical that it needs to be done on user, right? Because they need to be sure that like, cool, I want to create a verifier that will verify, yes, if this like proof, making sure that it's come from the data that I select and it come from the same computation graph that I want, which is the request computation. And on data provider, it's the same thing. It just create the proof and then yeah, send the proof here, the verifier verify the proof, and yeah, just making sure that the data commitment is the same, that the data set that we selected, right? To make sure that data provider use the same data that the user prefer. It looks fine. Like, okay, cool. We can like do stuff. We can use ECKL. Once we frame the problem, it looks fine. But yeah, what are some challenges, right? So basically, like, there's a few that I think is really like worthy to mention here. So some challenges with the ECKL is that, like, again, their library is that it's really good. They're given Onyx file, you can create CKP. But again, like in this case, user need to write their PyTorch computation, which can be exported to Onyx file, right? However, a lot of operation in Onyx or like on Onyx format is not really supported by ECKL in the ZKP, and that can be limited to some of how like Onyx file is processes. So basically, like some function is tricky, like if-else statement, like it is pretty tricky to represent that, and in ZKP from Onyx file, it's really Onyx file pretty much like represent misleading information, something like that. So we want to make sure that like when allow users to write statistic function, they don't come up with error, right? So we just want to make sure we just write wrapper function so that users can call like almost like we make sure to support like Python statistic operation. So it's like mean, geometric mean, harmonic mean, like this stuff, like median, mode, those stuff. So we want to make sure that like users can just call it without error. So first thing is that we need to write the wrapper. So in this case, you can see, right, like you can just, this is all the user needs to do. Like they just write some computation graph, this is just like Python. So basically, again, right, we can request from multiple data set as well, as long as it's come from the same, like one individual data provider. So in this case, what we do is basically we call like, cool, we want to calculate median of this data set, and then median of this data set, and then calculate mean of this data set. And yeah, this reshaping is just some tricky things to do with this here. It's not a big deal, but basically you can just put it at the end of the result. So basically the code is pretty simple. You can just like call median, mean, and done. And that's the first thing that we just make sure to write wrapper, because it's not like one size fits all solution. So we want to make sure we write some custom functions to support this thing. And yeah, this is how we cover it. We make sure to cover all like eligible Python functions, stat function in Python library. More interesting or like more deeper like ZKP related. So if you guys know about like zero knowledge proof, right, the bottleneck is that it's really slow to generate proof, and the bottleneck is that like the circuit size can blow up really fast. And when talking about circuit, right, the thing that represent in circuit is pretty much the field number, which is field element, which is basically the integer, right? So it's pretty tricky. You cannot just represent floating number or like decimal in circom or like those stuff, because it's really tricky. So the way we handle with floating number, which will be our favorite number for statistic operation, right? A lot of floating number point, like, and it's really matter. So the way we do that, we need to scale it up. So basically, like given, let's say you have like 1.5, right, as a number, you need to scale it to integer. In this case, it's easy, right? You have to times 2 or something like that. But if you have some weird decimal, you have like 1.1326, something like that, you need more scale up. And when you scale up, it's kind of like screw up the circuit, because you just scale up everything, and the circuit size just blow up so much. And then this thing like apply as well for like division, for like exponential, like all this stuff, that you actually need some lookup table so that it can just like fit all this like possible result from nonlinear function, right? Because nonlinear function like e to the something is just like really like huge, and the circuit can blow up. So here was the solution that we like think, and we already tried out and we implemented that hugely improve it. So instead of computing the result directly, in this case, let's say if we compute some nonlinear function like geometric mean. So how do we do that, right? We just multiply everything together and we take the end root of that. Instead, we just pre-calculate the result, which means that like we calculate this result outside of the circuit, just like use normal computer to calculate the result, and then just prove that it's actually within the acceptable calculation error of the real result. So that like the good thing is that like we don't need to actually like calculate it inside the circuit. We just calculate it outside the circuit, and then have the proof that it's actually within acceptable calculation. And why does that save? Like let's look at the example of geometric mean. So this is naive things, right? So this is pretty bad. Like let's say if this number, each number is like, let's say 1,000, and you have like 1,000 of it, like 1,000 to the thousands exponential power, that's like blow up lookup table. The circuit is really big, and again like this 1/n root is pretty bad. So yeah, sure, we can optimize it to become like more naive version, so that instead of like multiplying huge number, we can take log of it. We can have e to the something, but this still blow up, right? Because e to the something is still like, it's still nonlinear function, and it's still blow up. And the division, again, what division bad is because it costs floating number, which we need to scale again. Like anything go up with division is pretty sad, because we need to scaling up, because again, zero knowledge proof doesn't really support like floating element. So the way we do that is basically we just calculate this as a result. So we call it RES, right? It's the pre-result, and then we want to check that like this result is actually within like some percentage, acceptable percentage error from this, right? So basically we just calculate this like RES, and then making sure it's the same, like close enough to this thing. And then to prove that they're quite similar, it's pretty like you don't need to actually calculate that, right? In this case, you don't want to calculate e, right? Yeah, that's fine. You can just take log of it, so that this like look ugly like formula is basically just like making sure that like this rest is on really close error from this thing. But then like you can just like get rid of E by taking log on both sides. You can get rid of the division by take like multiplies N on both sides, other stuff. So this equation just make it really easy for zero knowledge. You don't need like E to the something. You don't need to have division. You don't need to scale like this stuff. So we're making sure that like all of our supported stat function is like instead of calculating directly, and things get worse, right? When like you do like standard deviation, like or like harmonic mean, which is just like a lot of division and stuff. We just want to make sure that like we write each of that function into this term. That's just like save the cost in the circuit, more efficient. Last but not least, that I want to mention here is about filtering, right? Because like the data set will be useless if you cannot filter. Like let's say you have like X and Y column, and you don't want to just like consider some stat function or like some insight of this like X column given only like Y like less than this. And in Python, it's really easy to write that. Like you can just like write this, and then it just filter out for you. But then this is really hard because you cannot put this into zero knowledge circuit. Why? Because like in the circuit, they need to have predetermined size of this everything, right? And then if you like have X, have Y as an input to circuit, and then you calculate this thing inside circuit, like the circuit doesn't know before like what's the result of this, right? Like let's say X may be like 40 rows, and they don't know that like the result of this will be 20 rows or like 10 rows or something like that. They don't know how many numbers. So it's pretty hard to do that. It's actually impossible because in CKP, in zero knowledge proof, you need to make sure that you have predetermined size, right? So yeah, the solution is that like instead of just allowing people to do that, we just again need to write a wrapper function of this filtering, and this wrapper function basically need to make sure to preserve the size because the zero knowledge proof need to have the predetermined size. So basically, yeah, let's look at example, right? Let's say we have X here, which is like just like 6 numbers, and then like let's say filter X given like for X greater than 8. This is just our wrapper function, right? And then yeah, instead of like getting rid of everything and becomes just like 3 size array, that's not possible for CKP. So we just like replace the non-satisfied like element into like some number M. So let's say M can be any arbitrary number that's unlikely in data set, right? And then from that, like which like statistic computation you use after that, you can just like substitute M to be that like corresponding number. Like when you mean like let's say mean, right? For mean, you basically just need to sum everything and divide by the number, and then in number you can like in this case you just put like M as 0, 0, 0, and then you can sum everything and divide by 3, which can receive for like counting non-M number here, right? But then again, like it can be different. We use M here because like if it's like let's say like mode or like median, right? This like M can be something else, right? Like for mode, it can be like some random number to make sure it's not like the same as the real mode. For like standard deviation, you need to make sure it's become like the mean of the data so that it don't like change the value, because the challenge is that like we still need to have the same size, but we want to make sure is that like given the same size, we will still result in the like correct like statistic operation. So yeah, I think that's pretty much takeaway from ZKStats. But again, I think we think that ZKStats is not the end goal, because even though we can request like arbitrarily stat operation on multiple data set, it still just require one data provider, right? So in order to making sure that we can continue this with multiple data provider, that's why we further develop into MPCStat, which will have Kevin speak on that.
Thanks for Jer about the introduction to ZKStats library. Yeah. And yeah, okay.
And can I interrupt you for a question? Then I think we kind of like in the stage. So if anyone have a question for what Jern just shared, you can ask now, or you can raise your hand, or you can put your question in the chat.
Yeah, hello.
Yes, please.
Yeah, so I wanted to just get back what he was talking about, how he solves the part where a user can query, like let's say, give me the first 100 rules. Like I was also thinking about that as an edge case, whereby like he can get the information. He was talking about how like he solved it, but I didn't really get it from him. I wanted to know if you can just go through it again, like briefly.
You mean like how to prevent data leaking from some computation like requests, right?
Exactly.
Okay, yeah. So basically, like right now we it's pretty like non-automated because we think that like it's still not the best way to like, I mean, we can always have some algorithm to filter that, right? But it's actually in our roadmap. But right now, we're just making sure that on the data provider side, they can see the code, like they can understand the computation graph really easily, so that they can like see that, oh, this guy just obviously requests some raw data or like some raw data plus one or something like that. So I think our solution right now is that in order for this whole process to work, like the data provider actually need to click approve. It's not like automatically approved by our system to send the request like result to that. So we just make it easy for a data provider to see like what is requested, and they need to manually click it right now.
Okay, got that.
I think I saw this question. Are you already collaborating or building this on top of any CKP network? Can you clarify what do you mean by any CKP network, like blockchain or like Lasha? Yeah, I mean, if you guys mean blockchain, we don't really put this thing on blockchain yet. It's just like library in like cryptography library. Yeah.
Okay. We still have time for some question. If not, we will continue the talk right now. We will just wait 1 more minute.
And another question.
Yeah, please.
Yeah, so I wanted to know if why they didn't try it in this way. I understand that you can use the Onyx file in PyTorch, but like maybe if you use like something like a LangChain that will turn it into like an SQL query kind of, then you can now know, okay, maybe you can blacklist certain things about the SQL query so that then it's prevented the data leakage. Like maybe you know that, okay, if this SQL query means that you're getting this amount of information that you feel like you're not supposed to give out, and you just blacklist that with a regex kind of, so that like prevent it from going.
Yeah, good question. Actually, it's funny because we consider a lot about SQL. So like at first our project is called Proof of SQL. But yeah, actually when we think about Onyx file, we think about like how to make adoption like easier, and we think like the data science community just obsessed about Python. So that's why we're thinking that like maybe it's easier to onboard people to this like statistic on the basis of like people who already use Python. But yeah, on SQL side, I think we can use that as a like to manipulate data first, right? And then get into the pipeline. And then like after that, we can do statistic on top of that. But yeah.
Okay, cool.
Okay, great. Thank you, Jern, and for the question as well. I think we will move on to the next one. Kevin?
Okay. Yeah, thanks for the question. And I'll keep going. So about the MPCStats library. So it allows user to query to multiple data providers, and it's powered by MPC, multi-party computation. So the technique introduced in the last talk in this series. And yeah, so when using MPC, data providers, their data sets are the private inputs, and user will run the MPC with the data providers on this computation, on the user-defined computation. And after that, the user can learn the result. And we want to support data sets concatenating and joining. So for example, in this computation, data 0 is from the provider 0 and 1 from 1, and they can be concatenated and calculate the mean. And in this example, so it's calculating the average BMI, where the height data is from the data provider 0, and weight is from 1. So they can join the data sets on the ID and then compute the average. So how we are building MPCStats library. So so our first step is to start with the framework called MPSpeed. So with this framework, we can define computation with their Python DSL. So for example, here we read the input from data provider 0 and another input from 1, and we can just do the addition and multiplication and reveal the result. And MPSpeed also support many MPC protocols. So based on given different security models, they have different MPC protocol implemented. So once you define a circuit, once you define a computation, you can run it with different MPC protocols by just changing your command. So it's pretty easy. So we decided to use MPSpeed for now because their DSL, with the DSL, we can support all of our statistic operations and data filtering, and yeah, and after we implement all of the functionalities, we just run the computation. We can just do the benchmarks with different MPC protocols, and then we can, based on the benchmarks results and the settings we want, we can determine which MPC protocol to use. So after deciding the framework, MPC framework we want to use, well then we can start to implement our MPC stats library. And we found that we can reuse our ZKStats library we introduced before. So so it's the flow for the ZKStats library. So it's written in PyTorch and transformed to Onyx and then Hello 2 as a proving system. So we can reuse it just by transform it from Onyx to Keras to Circom into the arithmetic circuit that the Circom to arith-C define. So these paths are possible with these tools, but we still need to confirm. But in theory, they are working. And after we have the arithmetic circuit, so the arithmetic circuit looks like this. So it will be a sequence of gates, and we just need to write a loader. So for example, MPSpeed loader. So the loader just parse this circuit and do some pre-processing and translate the circuit into the corresponding code in MPSpeed's DSL. So for example, this is add and mul. So we just write a translator loader, translate these into the corresponding operations in their DSL, and then we can get the translated circuit in MPSpeed's DSL. So if you're interested, you can check this QR code out. So we have some code, but we haven't sorted it out yet, but it is working. Yeah, so with the path in the last page, there is some advantage for us. So for example, we only need to write, we don't need to write the MPC stats library again because we already have it. And So we don't need to implement it for many times. And if we want to support a new backend, we just need to write a new loader. So for example, we support MPSpeed. We have a MPSpeed loader and MPZ. Then we have a MPZ loader, and etc. So they will work pretty similarly. So doing something like this. So this is our next steps. So we will still focus on the MPC stats, and we will finish the flow, the path we mentioned by reusing the ZKStats library. So we need to check each step in the path works. So Onyx, Circum, etc. And after that, we can do the benchmarks and then determine which protocol to use. And we can also refine the MPSpeed loader we mentioned before. So people can reuse it to write Circum code and transform it to MPSpeed. So you can do MPC with Circum as well. And so after the refinement, we will have a template loader. So we can easily modify it for new backends like FHE. So we can try FHE. And for the platform, we will ship the first version with the ZKStats library. And after the MPC stats library is ready, we can just support MPC stats library as well. So by the time people can use our platform with ZKStats library and MPC stats library. So the potential future directions. So we also wanted to have a way to detect data leaking computations. So I think it's asked by the audience before. So even though ZKP and MPC So ZKP and MPC they only secure the process to avoid leaking their inputs, but the outputs can still leak the inputs. So for example, in our framework, the filter is necessary for users, and the filter can easily be used to leak data. So in this computation, data 0 at this ID will be leaked easily. Yeah, and another example is that in the MPC settings, if the computation is like this, and we have data provider 0 and data provider 1, so the data provider 0 knows this, it knows the sum of its own data. So it has the output, and it can just subtract and get the sum of the inputs from data provider 1. So these are the cases that outputs can leak inputs. So for now, we just set data providers to check whether each requested computation is safe, and yeah, they need to do this on their own right now. So it would be great if we have a automatic mechanism to detect for us. And we also want to integrate other protocols as well. And it may introduce new use cases as well. Yeah, so thanks for the people mentioned here for the ideas and the technical support. So that's our talk. And any question?
Kevin, we have one question in the chat room. You might take a look.
Computation between two input circuits.
Yeah, I can hear. Okay, yeah.
Okay. No, go ahead.
Okay, so the question is, when you do operation between two input circuits, is it based on homomorphic encryption? If not, how is safe to do operation? In terms of CKP, because like we just request the computation to data provider, right? And data provider just do it all locally. So that is safe because they just do it locally and they just return the result with the proof. For MPC, again, we just have MPC operation so that like it's all like magic of cryptography, so that you have like local data and then you just like come up to the like center to the MPC and spit out the result. But then again, like for FFHE, yes, it should be like homomorphic encryption. Yeah, everything done in local, yes. Local of the data provider, yeah.
Question?
Yes, please.
I want to know if the presentation slides will be available after the presentation. I wanted to go through like much more deeply.
Sorry, I didn't understand it.
But I was asking if the slides, like the presentation, will be available after this call, so I can go through much more deep.
Yeah, sure. Yeah, definitely.
Yeah, we will upload to the YouTube channel, and then I will send out the link through the email you registered on the event page. So maybe later today or tomorrow, I will send out the email.
Okay, thank you very much.
How to cope with the situation, like final slide with differential privacy. So yeah, we know, we heard of differential privacy, but we didn't dig much into that. So it will be explored more in the future. So at the moment, we are not sure how to do that properly.
Yeah, like right now we just use it a bit like, or maybe like framework to educate the data provider, right? To know that like, oh, is it leak or not? But again, with differential privacy, we can adjust the result a bit, right? To make sure it's like differential privacy. Yeah. But as Kevin said, we haven't like, because we feel like it's different part, right? We can add on top of the result. So I think we can add it later if it's needed.
How will be different for users when using ZKStats and MPCStats? So in ZKStats, you can only request to one data provider, and MPC you can request to multiple. And at the moment, so in ZKStats you will get a zero knowledge proof after the request, so you can share the proof to others. And you can also request the computation, and you just go offline, and the data provider calculate and generate the proof, and you receive it, and you're convinced. So you don't need to compute interactively with the data providers, but with MPC stats, both the data providers and users, they need to be online and they need to run the MPC, and user can get convinced. And there isn't a way for now to share the proof. So in MPC, there isn't a proof, but yeah. So I think that's different. That would be a different experience.
Yes.
I wanted to ask about, in general, statistical functions, like to generate in general proofs and compare to statistical functions. And while explaining the statistical function, can you mark which party or which entity is the trusted party?
Sorry. Sorry, I didn't understand it. Could you repeat that?
Yeah, I'll write in the chat.
Oh, thank you.
And the last question, my last question.
Yes, please.
I wanted to know like where can I receive meet the presenters after the program? Maybe like if I want to ask better questions.
So if you mean after the presentation where you can ask the question, right?
Yeah, like maybe I have better questions.
Yeah. You can visit the PSE Discord, and I think there is a channel that you can ask questions, and we'll be there. But I mean,
Yeah, just add on. So you can find our Discord channel link in the event page. So we have this open channel for people to ask question there. So yeah, feel free to join our service and then ask question there. Cool.
Okay.
So
Yeah,
next,
thank you very much.
no worry. Move on. Ask question there. Nagu, you will be next.
We haven't explored it yet. So I think that depends on the protocol, MPC protocol we use. But so at the moment we haven't decided yet. So we are not sure about that. We don't know about that.
It depends on, again, like the malicious setting, right? You're like semi-honest, malicious setting, and also on protocol, like different, because MP speeds is actually the aggregated list of protocols, so that we need to do benchmark on all of that as well. But yeah.
Okay, Nagu.
Hey, thank you. Did you guys done any benchmarking on, let's say, very simple, standardized, like a hypothesis testing, like a t-test or a chi-square test or all of it?
Sorry, I didn't understand it as well.
Like typical statistical analysis, like if you have a data set, it's very common to do like a simple hypothesis testing, right? Let's say you have two variables, you want to know whether their means are same or their medians are same. So typically you do this through hypothesis testing in stats. Like a t-test or chi-square test or ANOVA. These are like standard statistical analysis tests. Like, are there any benchmarking on any of these things? Like how well the ZKStats performs versus like a standard.
How will we perform benchmark?
Yeah.
So at the moment, so Jern, could you answer that?
Actually, we don't have explicitly standard about like PTS, TTS, but we do have like the standards for like speeds or like those stuff of the like traditional like statistic operations. But yeah, we definitely like cleaning up repo right now, and yeah, that's really good. Yeah, thanks very much, Nagu, for suggesting to have
simple
this.
Like personal experiments. Like you pick a ton of data sets, open data sets, just to see how well the ZKStats performs or doesn't perform. Because I would assume definitely it should be pretty good when you are doing some mean related statistics, but as soon as you want to do some median, kurtosis, things like this, then I think performance will be severely degraded because of how the setup is done.
Yeah, we do benchmark all that, but yeah, we publish result, and especially with the context of like PTS, TTS, hypothesis testing. I think when put into that context, it would be nice to see the result like in that context as well. So thanks very much. Yeah, understand what you mean.
Can you explain a little on statistical functions? Right now it is out of scope because we haven't confirmed that yet, but we will do it after the benchmark as well.
Yeah, so the what in my slide, right, that says like trusted party right now, it's just to make sure that the data commitment, right, the encrypted version is actually from that data. But again, on the flow of like requesting the computation, on the proof that the computation is done on this data set or not, like this stuff is not trusted party involved, so it's out of scope. But yeah, just on the beginning, right, to make sure that the data provider doesn't put some garbage into the claim to be dataset. Yeah.
Thank you. Sorry, I was talking about the MPC part.
Oh, you want to?
No.
Oh yeah, please. Yeah.
No, I was talking about the MPC part. So I think I misunderstood the question.
Okay, guys, we have a time for one more question. So raise your hand or type your question in the chat. And then, like I say, afterward, we will upload the recording to our YouTube channel, and I will send the link of the slide and the video as well through the email. So check your email if you wanted to know, you wanted to watch the video. And also, if you have a question after this, you can go to PSC Discord channel we have a space there for public to ask questions. So yeah. Great. Do we have more questions from the audience? Cool. We have the last slide. I'm sure the reference. Can Kevin present that, please? The next. Yeah, this one. Yeah.
Oh, yeah, it's just the project we have referenced in the slides. So yeah, if you're interested, you can check it out. And for the MP speeds, we have a fork because right now our MP speeds loader is implemented in the fork branch, and we will separate it out in the future. So if you want to check out the MP speeds loader, you can check the link. Yeah, and I think and the circum2 arithmetic circuit, it is developed by the MPC research team. So you can transform the circum2 arithmetic circuit, and yeah, you can try it out, and you can do something with the arithmetic circuit like us, and maybe you can find some new use case and find some way to work with MPC. Yeah.
Cool. Thank you for sharing. Before we wrap up, Jun, you have something to share, though?
No, yeah, that's all we have. And yeah, as Kevin mentioned, that we have Discord in PSE, and yeah, we welcome the suggestions, everything. Again, like there's a lot of things that we need to polish and we need to improve upon as well. So we welcome all your guys' feedback, and we appreciate for joining our call today.
Great. Yeah, thank you, everyone.
Thank you, everyone,
for coming. I will see you next time, though. Bye.
Goodbye.
Bye bye.
Thank you very much.